Okay, the purpose of this video is to show you how to use your TI-83 and TI-84 calculators to solve systems of equations that look like this. The first thing is that your equations need to look like this. You need to have your equal signs lined up, the constants over here on the right, and then a's lined up with b's, lined up with c's, or x's with y's with z's, or whatever your variable names are. The second thing is if you have a different calculator, you'll have to work with each other to try to figure out how to use it, but it'll be somewhat similar. So the first thing I want you to be able to do is to rewrite this using what's called a matrix equation. This is what you'd expect. It is an equation, so there's an equal sign, but it has matrices rather than the stuff we're used to. So it's not very hard to do, so to write it, I'm going to construct what's called the coefficient matrix first, which are just the coefficients of each of the variables on the left-hand side. So -1, 5, -1. If the variable is not there, you would just use a 0 as a placeholder. If it's just the variable, remember there is an understood coefficient of 1, but that doesn't show up here. So this is my coefficient matrix. Coefficient matrix. And I'm going to multiply this by a column matrix composed of my variables A, B, and C in that order. So whatever your variables are, you write them here. And then on the right side, this is -25, 3, -21. -25, 3, -21. And this is the variable matrix. So to solve this system, what I'm going to do, and this is the theory of it, I'll just talk through it. I'm going to multiply both sides on the left by the inverse of this matrix here. So what that'll do on the left-hand side will be the inverse of the coefficient matrix times the coefficient matrix. Anytime you multiply an inverse times a matrix times the same, or an inverse matrix times whatever that matrix is, you'll get the identity matrix, which is the effect of getting the identity matrix is that matrix times this will just create A, B, C on the left. On the right side, we want to multiply again on the left. This is to keep things balanced. The inverse of my coefficient matrix. So the way that we write that, oops, sorry, this should be a -1, 5, -1, 5, 4, 2, -5, -1, -5. So I want the inverse of this, so I use this little -1 symbol to indicate inverse. And now multiplied by -25, 3, -21. Now this is what I want to enter into my calculator is this matrix, which I'm going to call matrix A, and this matrix, which I'm going to call matrix B. To do that, I'm going to go into the matrix menu. So second x to the -1 is where the matrix menu is. I'm going to arrow over to edit and edit matrix A. Matrix A is a 3 by 3. 3 rows by 3 columns. So enter in the dimensions, 3 by 3. And then we need to enter it in here. And I've already done that. -1, 5, -1, 5, 4, 2, -5, -1, -5. Double check. Any single mistake will make all of your calculations wrong. Now quit back to the home screen, go back to the matrix menu, and edit matrix B. So that's number 2. This is a 3 row by 1 column, so a 3 by 1 matrix. Enter in the numbers, -25, 3, -21. Quit back to the home screen. Now I'm going to multiply A inverse times B on my calculator. So the way to do that is to go back to the home screen where I am. Second matrix, use the names menu. So I'm going to select A. The -1, x to the -1 is the inverse command for matrices. So A inverse times, press the multiplication symbol. Second, x to the -1, back to the matrix menu. Select B and enter. This gives me the solution to the problem. So ABC equals the column matrix 3, -4, 2. So that tells me that A is 3, B is -4, C is 2. This is the solution to my problem, and this is really the power of matrices, is it gives me a quick, efficient way of solving systems of equations. If you remember from previous courses, if you've ever solved a 3x3 matrix by hand, it can be sometimes a lot of work, easy to make mistakes. Calculators don't make arithmetic mistakes, so if you enter the matrices incorrectly, the calculator will quickly and efficiently give you the answer. So this is a really nice, efficient way to solve systems. But again, they have to be in this form. If they're not, you need to make it so. So that's all that's expected for this. Make sure that you write your matrix equation, and you can type these matrices into your calculator, do the multiplication, and then indicate a final answer.